Benita made a great video describing how he got Microsoft BASIC running on his 6502 breadboard computer. And I thought that would be a great project to do as well for my Famicom. Now, the Famicom already has a variety of BASIC available for it, Family BASIC. And it's based on another version of BASIC, or Hudson BASIC. So there are differences between the two, but it was never officially released on the NES. So I wanted to make a version of BASIC that is more freely available. So I used Benita's guide, Benita's video that he made, to help me to port Microsoft BASIC to the Famicom. Once again, I'm using my keyboard interface, but it should also work with the Family BASIC keyboard. I've also decided to make it available in two mappers, so you have a wider range of characters available. And again, my fork of Microsoft BASIC for the NES is available on GitHub down below. So let's have a look at the changes that I had to make. Once again, I had to make quite a few changes because of the architecture of the Famicom compared to a computer that has chips specifically designed for displaying text and reading keyboard input. I had to go through most of the same process as Benita, trying to build it, seeing what errors came out, adding in solutions, fixing those errors, adding in more and more code. But I didn't really have to change any of the base code of MSBASIC. It was mostly just additions to handle the functions that the program was already calling. So we'll start off the defines, right? We look here, we're in the MSBASIC S. The first thing, I think there's only effectively three pages that we have to look at. First one, defines, right? So let's look in the defines.s. Let's go. Right, we had to add a defines for our NES config. I did not need to add anything else down here. Right, we just needed to add a custom defines file for the NES. Right, so let's have a look at the defines nes.s. So what am I defining in here, right? We have our configuration, picked a configuration version. This is which version of MSBASIC we are running. The scratch, delete it again. Alright. The SCR/TCH order, again, I think it was the same as Benita. It didn't seem to make any difference whether you set that or not. This one here is interesting. The mon c out destroys y. My output will use the y register, so this config setting backs up the y register before calling mon c out, and then restores the y register afterwards. And there's no CR, no carriage return. Effectively, it doesn't add extra carriage returns to the output. And then we have one more config here, which is for my NES, the 1K char RAM for mapper 218 for my particular cartridge. We set up a 0 page where these blocks of 0 page are in the 0 page memory on the 6502 and on the Famicom. And there's one more block of 0 page. I've added ZP start 5. These are some more 0 page variables that I need with my port. Some extra 0 page variables. This one here is, see, I've got a comment here. We need to set this here for the NES is CNTC, which is the is control C. Right? Are you trying to break out from output? I've got some constants in here. We put the stack top. We go for the go sub, the width. And I've got a constant here for the C key, what ASCII value C key is. Memory layout, we have the memory, the RAM starts at 6000. That's the prog RAM area where the output buffer and the keyboard, family keyboard input monitor live in memory, 3000, 3030. And the NES control registers are all in here as well. So that's the defines. Those are the things that get defined. Right, so that's the first part. The next part is in this header.s. Luckily, this header.s is where we have our header segment, and so we can add for the NES all our header data in here. The NES header, the ISR segment locations, the address we're using here for reset is NES reset, is where it's going to jump to when the console resets. See, I've got a config in here for my 1K char config for mapper 218 and for mapper 0. 1K char RAM or 4K of character RAM. The 4K of character RAM has the lowercase characters in it as well. The 1K character RAM, we don't have enough space to have that many characters, that many tiles. And for an emulator, it also sets the expansion device to be FamiBasic keyboard. Alright, so the next, let's go back to the, now we're going to go into the meat of it, the extra.s. Right. We have one more here. Add a def for NES extra.s. Right, so we'll head on to this one here. That's alright. And oh, I've done a bit far. Here we are. So I'm setting up 0 page. Right, these are my 0 page variables for ZP Start 5. We have 4 bytes for the mouse read, 4 bytes for the keyboard read, 1 byte for the keyboard read pointer, 1 byte for a temp area, 1 byte for the keyboard detect, 1 byte for keyboard input, 1 byte for mouse input, 1 byte for the ready, for the NMI ready, 2 bytes for the vertical scroll, 1 byte for vertical scroll Y, Y save 1 byte, Y out, and row all get 1 byte. Right, so that sets up the last of the ZP 0 page variables, and then we go into our code. I'll reach the NES reset. Right, so this is where it will jump to on a reset. Right, we have our standard NES startup sequence. Right, clearing the decibel mode, sorry. Disabling the APU, setting up the stack, disabling rendering, waiting for VBlank, clearing RAM, loading the palettes, loading the name table, and loading the char RAM, like the char data, sorry. And then we enable rendering, initialize the keyboard, right, so we jump to this keyboard init, we set up the scrolling, and then we jump into cold start. Right, and cold start starts MSBASIC itself, right? And then directly below this, we will start the routines. So if the routines called to be called from program, right? Well, the save load routines, I haven't done those. I have a goal to do these. I have a goal to emulate the tape drive, the data recorder from FamiBasic, and to use these save load routines to save data onto that device. But that's in the future. We have the monc out, right, which will output characters to the screen. We're ignoring the flash cursor, right, called bell. We push the A, the value that's on A, and we have to pull it back out just to make sure because it might be used. We ignore line feed characters. If it's a carriage return, we have to go down to a new line. Right, this most of this is coming straight out of the echo statement from Nesmon, from the Wasmon port. Right, store it into the display, and otherwise, right, we convert the ASCII to the char RAM tile, and then we store it into the output. Right, clear the line if necessary. Yeah. Right, we compare where we are, how far our cursor is across the screen, and if we need to, we'll go down to the next line. otherwise return out. We've got some of these parts for keyboard. Right, I've got here keyboard ready. This gets called by the NMI. Right, most of this is copied out of the Nesmon. Right, my goal was basically that the keyboard.s be able to be dumped into other programs with little change, and in that way be able to import keyboard handling for those programs on the Famicom, on the NES. So we've got our keyboard ready. It's the same as in the Nesmon. Right, we're checking if we've got keys in the buffer already. We're checking if we have to load, like read from the keyboard again. Well, I guess a good way to put this, right? I've effectively got two buffers. I've got a buffer in the console and a buffer on the interface. And when the Famicom reads from the interface, it'll read any keys that are in that buffer into its buffer, and then each one of those keys has to come out and get processed before it will go looking for keys from the interface again. That could mean that some keys on a real hardware, real Family Basic keyboard could get lost, but this should be very fast, so it's unlikely that you would lose keys that way. Anyway, got a way to clear the buffer. It might be necessary to clear the buffer at times. I've got a way to read the key silently, right? This one here, call this during output to prevent echo to the screen, right? Usually when you want to check, I think this one's used for the Control-C check, the break check. We need to see if a key has been pressed. We don't want to call this one here, the mon read key. We don't want to call this one, because this one here will end up putting keys onto the output. Instead, what we want to do is silently check if we've got a Control-C that's come into, or Control-C has been pressed, right, during output. So we have this one here. This is our mon read key to read in keys from the keyboard. It is also named the read keyboard subroutine. It is basically the same as from Nesmon, but we just added a new label, mon read key, to it, because that is the label that MSBASIC uses. Now we've got these internal routines, right? We've got the keyboard in it, same as from Nesmon, right? We're looking for the Family Basic keyboard, then we look for the keyboard mouse host. If we don't find either keyboard, then we loop, we wait until we get one of those keyboards, and then we continue on. So remember, this one here gets called before running cold start. So before MSBASIC starts, we will wait until we get a keyboard. And then most of this is the same, right? Checking mod keys. Which ones are pressed? Is a key pressed? Right, we've got a check here for, is a control key held? If it isn't, then we go down for the shift keys, checking shift keys. If it is, then we check to see if it's a C that's being pressed as well, like control. Is control being pressed? Yes. Is C being pressed? If it's not, then we branch to restore action. If it is being pressed, we're going to pull A, and we're going to AND it with 03, which will return the Control-C code. And then you branch out, exit with break. We've got that there. It's, are we getting a Control-C in? Right? Has the user pressed Control-C, return the Control-C code. And then we've got checks for the shift, right? Lowercase. In fact, what I've done in here is that the default is uppercase letters, because all the macros in MSBASIC are uppercase, right? If you type print in lowercase, it doesn't understand it. So the default is to use uppercase. But if you want to use lowercase, use shift. That's the way I've got it. So if you want to print something out which has lowercase letters in it, you use shift to enter the lowercase letters. I know it's opposite, it's just a choice. My shift map I actually use the very last bytes in the 0 page to point to the shift map that I'm using, depending on the keyboard, which will speed up referencing the table. Right, so we're going through this. Not quite sure why this restore action here is blue. Who cares? Might be because I got these spaces until the thing here. Yep. Should be like that. Who cares? Whatever. Right, and then we exit with the mod check. You got multiple ways out of this. Right, restore action will RTS. Exit mod check will pull A and then RTS. Exit with a break will just RTS. And then we've got our subroutines to read from the keyboard. Read input from a keyboard mouse host. Right. Setting the mod keys for the keyboard mouse host. Right. Reading from the FamiBasic keyboard, if that is connected, and setting those mod keys. A delay for reading from the FamiBasic keyboard. You need about 50 cycles in there. Converting the ASCII characters. So we've got another def in here for the 1K char RAM. VB weight, and then we've got more of these Famicom NES specific routines, right? VB weight, the original MSBASIC does not have a VB weight, it does not use NMI, so these are required for the NES, for the Famicom NMI handler. We do have the sprite OEM is being used. I haven't thought of a way to really use that in MSBASIC yet, but it should be available. But this is mostly the same as Nesmon as well, except for the 3 configurable interrupt addresses. I don't have those available in this. So we have the NMI, the IQ interrupts can be addressed, clear line, right? Scrolling, and then we have our final segment, the RO data, palettes, family keyboard map, the shift maps, the keyboard mouse host maps, and then we include the characters. 1K of characters if it's the mapper 1218, 218 I think, mapper 218 single chip cartridge, or 4K characters if it's mapper 0. Now there's one, or is it 2 more things I want to check. Let's go back to MSBASIC. There are 2 more I think I want to check. There's one which I think is not particularly visible. I can't remember where it gets loaded actually. It gets loaded somewhere. But it's called NES is CNTC.S. This is one that Ben Eater had to do as well. How to handle the Control C codes. So we have the silent read key. We check if it is the correct value for a C, ASCII C. If it's not, then it's not Control C, we just jump there. Right? We load our mod key, our modifier key, states. We end it with 11 because it could be the left side or the right side of the keyboard that the control is being pressed. Right? If those are neither of those are pressed, then it's not Control C. Right? I load A with 00 because that will set a 0 flag. The stop checks for the 0 flag. And then we jump to is Control C, which is down here. It will just fall into the stop routine. Okay, I'm going to save the last thing I was going to show for another video. But now let's demonstrate it running on the hardware. So I'll bring up the capture device and start the Famicom. So we start off with memory size. We'll just press enter here and enter for terminal width. We've got 8K of memory free, and we've got copyright Microsoft.co. Alright, so firstly we can print, right? We can print hello. We can make a little program. We can list it. We can list just the one there. We can run it. And we can control C. So those things are working fine. We can do a new. We can do for, what was it again? I equals 0 to 5, I think it was. 20 print. And you get an underscore instead of actually moving the cursor backwards when you do backspace. List. It prints it out 6 times because it's inclusive of the 5, I think. So the 0th, 1, 2, 3, 4, and also the 5th inclusive. Okay, so we've got it working there. We do have peek and poke commands work as well. 5, let's have a look here. Got 254. This 512 is memory hex address 0 to 100. Now this is the sprite IMDMA area, so we can change this, right? So I'm going to poke, what is it again? Let's put it down about 1 to 8, shall we? I'm also going to poke 13, 14, 15. 5, 1, 5, 1, 2, 8. And you can see it's moved a little character in there. So I can change that character. I'm going to change this character to 513. What's 10? That's a star. Okay. Let's go 513. Is that the wrong one? 11 plus symbol. I try to remember where my letters are in the 20 is, what is that? I'm not even sure what character that is. 30. Okay. Oh, that's an H. Oh, I've got letters finally. Alright. And right now it's green. I could change that as well. That'll have to be 514 to, what is it right now? Oh, it's going to be at a really high value. That's hard to read. That's what it was before, I think. Oh, now it's white. And so, yeah, that's the sprite IMDMA area, which is always getting updated in the NMI. So you could write a program which will write values into that area and will like animate things, draw things to the screen. So that is available in this MSBASIC. Alright, so I think I'm going to leave that there for today. And I'll be back with another couple of videos at least on BASIC on the Famicom. All the code is available on my GitHub, and we'll see you again.